Have you ever needed a Dataverse app to show data that lives outside Dataverse in a real SQL Server database without copying millions of rows overnight? That's exactly what virtual tables solve. In this video, I'll walk you through building a custom Dataverse virtual table provider in C# so a model-driven app can query live SQL data as if it were a native table. Dataverse, if you're new to it, is Microsoft's cloud database behind apps like Dynamics 365 and Power Apps, storing information in tables similar to spreadsheets. By the end, you'll understand the provider plugin, the data source registration, and how forms and views light up with real-time external records. Let's get started. Let's define our main character, the virtual table. A normal Dataverse table, think accounts or contacts, physically stores rows inside Dataverse's own database. A virtual table looks and behaves the same in forms and views, but it's empty on the inside. Instead, every time someone opens a view or a record, Dataverse calls a small program called a data provider plugin, which reaches out to your external source, here a SQL Server database, grabs the matching rows, and hands them back as if they were native Dataverse records. Picture it like a hotel concierge desk, no rooms of its own, but it instantly connects you to the right resource elsewhere. That's the mental model we'll build in code. Here's the full picture end to end. A user opens a view inside a model-driven app. That view is bound to a virtual table definition you configure in the Maker portal. Behind that definition sits your data provider plugin, which implements an interface called IExternalService, Dataverse's contract, for saying call me whenever someone needs data from this source. The plugin opens a connection to your external SQL Server database, runs a query, and packages the results back into Dataverse's expected format. Notice the highlighted box, the provider plugin, that's the piece of C# code we're about to write together. Everything else already exists, we're just wiring them together. Before writing any code, your external SQL server needs to accept incoming connections from Dataverse because your plugin runs inside Microsoft's secure sandbox environment, not on your own network. An endpoint, by the way, is simply the network address a service listens on, like a shop's front door. Here I'm in the Azure portal, looking at my Azure SQL database called Sales Catalog DB. I'll open the networking blade on the left menu. This is where firewall rules live, the gatekeepers deciding which IP addresses are allowed to knock on that door. Without opening this up correctly, your plugin's connection attempts will simply time out, and your users will see errors instead of data. Now I'll add a firewall rule. See this start IP field? I'm entering the published outbound IP range that Dataverse plugins use for my environment's region 20.36.0.0. Microsoft documents these ranges per region, so you copy the correct set for wherever your Dataverse environment is hosted. This tells Azure SQL, traffic coming from this range is trusted, let it through. I'll also confirm enforce SSL stays on because credentials and data should always travel encrypted, never in plain text. Skipping this step is one of the most common reasons a virtual table shows blank views after everything else looks perfect. With the rule name and IP range filled in, I click Save at the top of the blade. Azure takes a few seconds to apply the change across the database's networking layer. Once it's done, any code running inside that approved IP range, including our future Dataverse plugin, can successfully open a SQL connection. This is a one-time setup per environment, not something you repeat for every table. With networking sorted, we can now shift into Visual Studio and start writing the actual provider code that Dataverse will call to fetch and shape this external data. Now let's scaffold the provider itself. In Visual Studio, I create a class library project and add a class called SQL Catalog Data Provider. This class implements iPlugin, the same base interface every Dataverse plugin uses, and internally we route messages using the IExternalService pattern for virtual entities. Look at the execute method. Dataverse calls this same method for every operation, so we check the context message name to decide what's being asked. If it says retrieve, we fetch one record. If it says retrieve multiple, we fetch a filtered list, which is exactly what powers views and lookups. This switch statement is the traffic cop directing every request Dataverse sends our way. Let's fill in retrieve multiple because that's the method a grid view actually triggers. Dataverse hands us a query expression object describing filters, sorting, and paging the user requested. I open a standard ADO.NET SQL connection using a stored connection string, run a straightforward select statement against my products table, and loop through the reader. For every row, I build a Dataverse entity object named SQL underscore product, setting its columns from the SQL columns. Finally, I package all of these into an entity collection and assign it to output parameters under the key business entity collection, the exact name Dataverse expects back. This is the moment external rows officially become Dataverse records in memory. With the provider assembly written and signed, we register it in Dataverse and tell the platform which data source type it represents. I'm in the Power Apps Maker portal on the virtual entity data source table, creating a new record called Sales Catalog SQL Source. See this data source type field? I'm setting it to Custom SQL Provider, a value that matches the class we registered through the plugin registration tool earlier. This single dropdown is what links your compiled C# code to any virtual table you build later. Get this value wrong, and Dataverse won't know which assembly to invoke when a view opens. Next, the data provider assembly field. I type in SQL catalog data provider.dll, exactly matching the assembly name you registered in the plugin registration tool. Think of this like addressing an envelope. Dataverse reads this field at runtime and says, go find this specific piece of code whenever someone touches a virtual table pointed at this data source. If the assembly name is even slightly off, spelling, casing, extension, Dataverse simply can't locate your execute method, and every view built on this source will fail silently or throw a generic error to your users. Last field on this record, connection string name. Rather than hard coding a SQL password inside our C# code, which is a serious security risk, we reference a named connection string that's securely stored using Dataverse's connection reference mechanism, here called sales catalog connection. Our plugin reads this name at runtime and resolves the actual encrypted value. Once all three fields are set, data source type, provider assembly, and connection string name, I save the record. This data source record is now the bridge. Next, we point an actual virtual table definition at it so makers can build views and forms on top. Let's see the payoff inside an actual model-driven app. I'm in Contoso Sales Hub and I've opened a record from our new product catalog external table SKU-1493 ergonomic office chair. Watch the unit price field, $249. This number isn't stored anywhere inside Dataverse. The instant this form loaded, Dataverse fired a retrieve call into our plugin, which opened a live connection to SQL Server, pulled this exact row, and rendered it here. If someone updates the price directly in SQL right now, the next time this form refreshes, you'll see the new number with zero data migration involved. Now look at warehouse stock, currently 37 units. Behind the scenes, every single time a user opens this record or refreshes this view, that retrieve multiple or retrieve method we wrote earlier runs again, hitting SQL Server fresh. That's powerful for accuracy, but it's also a performance conversation because a slow SQL query or a poorly indexed products table now directly slows down your Dataverse form. This is the trade-off virtual tables ask you to accept. Perfectly live data in exchange for taking responsibility for how fast and how efficiently your provider code talks to that external database. Before we wrap up, a few real-world lessons. First, every view and every form load can trigger a live SQL call, so add proper indexes and always implement paging. Otherwise, large tables will feel sluggish. Second, Dataverse sends you a rich query expression object describing filters and sorts the user chose, and it's on you to translate that into real SQL. Otherwise, search and sort in views simply won't work. Third, never hard code credentials. Always resolve them through a secure connection reference like we did. And finally, keep your ADO.NET calls lightweight because plugins run inside a sandboxed, time-limited execution environment, and a slow join can cause a timeout error for your users. Let's recap what you just built. You opened the network door on Azure SQL, wrote a provider plugin implementing IExternalService to handle retrieve and retrieve multiple, registered that assembly through a virtual entity data source record, and watched a model-driven app render live SQL rows as native Dataverse fields, no replication, no overnight sync jobs. This same pattern scales to Power FX formulas, Power BI reports, and Power Automate flows because to them, it's just another Dataverse table. If this walkthrough helped you, please subscribe to Carmons for more deep, hands-on Power Platform and Dataverse tutorials, and I'll see you in the next one.